Another great paper in the large language model space named CodecLM. Aligning language models with tailored synthetic data introduces a novel framework for enhancing LLM alignment with task-specific instructions using synthetic data, termed CodecLM. This approach significantly mitigates the reliance on costly human-annotated data, proposing a method to automatically generate high-quality, tailored synthetic instructions that better train LLMs to follow specific instructions. CodecLM leverages an encode-decode architecture to transform seed instructions into metadata, capturing essential characteristics of the desired instructions. This metadata, consisting of keywords reflecting the instruction context, guides the synthetic data generation to align closely with the target instruction set. The framework employs two innovative components during the decode phase: self-rubrics and contrastive filtering. Self-rubrics enable the dynamic adjustment of instruction complexity based on the metadata, refining the synthetic instructions to increase their utility for specific LLM training goals. Contrastive filtering further enhances the instruction selection process by comparing generated instruction response pairs against those produced by a higher-performing model. This step identifies and selects the most effective pairs for training, focusing on those that challenge the target LLM and thereby promote greater learning efficacy. Extensive validation on multiple open domain instruction following benchmarks demonstrates CodecLM/S superior performance over existing state-of-the-art methods. The results highlight its ability to effectively tailor instructions and responses, leading to improved instruction following capabilities in LLMs across various tasks. Potential improvements and future research directions include enhancing the metadata generation process to cover a broader range of instructional nuances and exploring advanced machine learning techniques to further refine the instruction tailoring process. Now let's understand more about the exact mechanism of contrastive filtering. Contrastive filtering in CodecLM operates by evaluating the effectiveness of generated instruction response pairs, leveraging a quality discrepancy metric to assess and select the most impactful pairs for model training. This method capitalizes on comparing responses from two different models: a strong LLM, a high-performing model, and the target LLM, the model intended for improvement. The process begins by generating responses to the same instruction from both the strong LLM and the target LLM. These responses are then scored using a predefined scoring function, typically implemented using the strong LLM as a reference. The scoring function evaluates how well each response aligns with the expected output, providing a quantitative measure of quality. The quality gap is calculated as the difference in scores between the responses from the strong and target LLMs. This gap is used to determine the relative effectiveness of each instruction in teaching the target model. Instructions leading to a larger gap are considered more valuable because they highlight areas where the target LLM/THES performance can be notably improved. Instructions that produce a high-quality gap, exceeding a certain threshold, are included in the training dataset, as they are seen as opportunities for significant learning and model improvement. Conversely, instructions resulting in a low-quality gap, below the threshold, are either discarded or sent back for further refinement through the self-rubrics process. This iterative filtering and refinement cycle allows CodecLM to concentrate on training the LLM with data that are most likely to improve its performance, thus making the training process more efficient and effective. The method ensures that only the most challenging and instructive examples are used, optimizing the LLM/S learning trajectory toward better instruction following and generalizability across tasks.